Okay, today we have to talk about matrix multiplication. And the thing to remember, before you even start to multiply two matrices, is it even possible? Okay, so that's the first question to ask. And the way to do that is to look at the size of each of the matrices that you are starting with, okay? So let's look at one for example. Okay, let's say that we have these two matrices. Okay, so the first thing to do is identify what is the size of the first matrix. And when I look at this blue one, it has 3 rows and 2 columns, so it is a 3 by 2 matrix. And then I'll look at the second matrix that I'm trying to take this times. It has 2 rows and 4 columns. Okay, so of course we would not be able to add or subtract these matrices, but now the question is multiplication. And here's how it goes. You're going to look at these middle two numbers, okay? So these middle two numbers have to be the same. Okay, so if those numbers on the inside of this dimensional kind of list that we wrote out here are the same, then it is possible, okay? And what's more is you can go further now. So this is where things get really kind of fun. You can go further and you can look at this and know what the dimensions of the final matrix are by looking at the outer two numbers. So the dimensions of the product. So not only is this possible to multiply these two things together, I know the answer will be a 3 by 4 answer. Okay, that'll be the size of the matrix for the answer. Alright, so let's write this down one more time. So in general, if I have the first matrix is, dimensions m rows by r columns, and the second matrix r rows by t columns, these are the same, so it's possible. Okay, so if inside dimensions are the same, and then I know the answer to the solution. Let's go different color still. Let's see, this is dimensions of the product. And m by t matrix is the answer. So real quick, could you multiply these two matrices together? Try this first one where I have the 3, 4 matrix times the -2, 5 matrix, and can you multiply them? What do you think? Find the size and then decide if you can multiply them. I'm going to say no to this one because these middle two numbers right here and here are not the same. Okay, so that would not be possible. Try this one. Okay, so I have a 3, 4, -1, kind of a column matrix, times this row matrix 2, 5. Find the size of each one and decide if they can be multiplied. So those are the sizes that I found, and I'm going to go ahead and say absolutely, these two numbers are the same. Those inside dimensions are the same. Therefore, yes, they can be multiplied. And not only that, I know this answer to the size of the product, a 3 by 2, is the result. Because that's these outer two numbers here and here. Okay? Alright, so now we can start talking about how to actually perform the multiplication. Okay, I'm going to attempt to multiply these two matrices together. Just checking like we always do the size of these things to make sure it's even possible. This one is a 2 by 2 times, this one is also a 2 by 2. So you'll look and you say, okay, the middle terms are the same. So yes, it's possible. But not only that, I know the answer is going to be 2 by 2 as the size of the answer matrix. So let's go ahead and get started. And the key comes down to, remember we always talked about matrices, it's rows and then columns. So this first matrix is supplying us with rows, okay? The second matrix is supplying us with columns, okay? So, here we go. Let me find a nice new light color. Alright, what we're going to do is we want to find the entry for the answer matrix, we'll call it A. So we'll say this is equal to big matrix A. So finding the entry for the 1, 1 position, first row, first column, one particular element, is going to come from, okay, the first row of the first matrix, okay, and the first column of the second matrix. Okay, so when we had A11, this one right here was which row to take, the row from first matrix, and then this other one told me which column to use from the second matrix. Okay, so now I've identified which row I'm going to use, which column I'm going to use. I'm going to have the numbers. So now what you do is you start taking products, okay? And you always multiply sort of the first number of the row with the first number of the column. So I'm going to say A11 is equal to, I'm going to take the -2, okay, that's this number right here, times the first number, -4, okay, and then I have to add the product of the second numbers, okay, so first numbers went together, and now I have to do second numbers together. So what I'm doing here is second numbers. So I'm going to take this one, still in the first row, but it's the second number in the row, with the second number in the column. So taking 1 times 2. Okay? So I can now finally figure out the entry for element A11 is going to be 8 plus 2 is equal to 10. So A11 is equal to 10. Whew! That seems like a lot, and it is, but it'll start going faster when you get the hang of it. Okay, so let's go ahead and try the another element. Okay, then I'm going to move up here. I'm going to go to A. This time I'm going to use the second row from the first matrix and the first column from the second matrix. So what are we talking about? Okay. I'm running out of colors, but so I have to use the second row. I have to use this one right here, the second row, and then I have to use the first column. So I'm still on this first column, but I've moved to the second row. Okay, so what's going to happen is, looking at this and this, put the first numbers together, 1 times -4, plus multiply the second numbers together, -1 times 2. And what do we get? You get a -4 minus 2, and you get a -6. So I know A21 is equal to a -6, and so far I have A11 was already 10. So I have found 2 of my elements for the matrix. Let's try another one. Okay, I've rewritten them. I'll remind you, I'm taking rows from the first matrix, I'm taking columns from the second matrix. So let's find some new elements for this matrix. So let's say I did A12, A21. I think I need A12 next. Okay? So what I'm going to do is this little 1 here says to take the first row. Okay? Then the second one here, the 2, says to take the second column. So those are the 2 things I have to take together and find this element. So, taking the first numbers, I get the -2 times 1, plus what happens when I take the second numbers, the 1 and the 1. Okay? So that was this -2 times this 1. Okay? Then I was going to take this second numbers, this 1 times this 1. Okay? Alright, so now I can evaluate that. I get -2 plus 1, -1. A12 is a -1. Alright, I have one more element I have to find, and that would be element A22. So when I go up to this matrix, I'm going to use the second row and the second column. Oops, let me do that again. Oops, I blew that, so I can't quite erase it, so let me try this again. And the second column, which is this one, okay? So, I'm going to put those together. I'll start with this first numbers on each of those. So it's 1 times 1 plus, when I'm looking at the second numbers, -1 times 1. So 1 plus -1, 0. A22 is equal to 0. So now I just have to put all those elements into an array called a matrix, and it looks like this. A12, first row, second column, -1. Okay, so this point, goes right here. Then I have A22, that's the second row, second column is a 0. And then I have to remember what the other ones are, but I've forgotten, so let me go look what those were. Okay, so going back, I found A11 was 10 and A21 was -6. So put those all in your matrix, and that is your answer for that product. Whew! Seems like a lot. Let's try it one more time. Alright, I have two matrices to multiply together. The first is a 3 rows by 1 column matrix, and the second one is a 1 row by 2 column matrix. So indeed, you look at this and you say, those are the same, okay? So it is possible. And then I know my answer. Let's say that's equal to A again. My answer is going to be a 3 by 2 matrix, okay? Let's get started on our multiplication now. Okay, piece by piece, let's work on A11. So I want the first row with the first column. Okay, so that's just 2 times 0, and there is no second number here. Alright, so that's just equal to 0. Let's do another one. Let's do A21. And we'll do that, let's do that actually in a different color. Let's do A21. So I want the second row with the first column. That's 3 times 0, which is 0. And then if I choose another color still, I can do A31. So I want this third row with this first column, and I'm getting 4 times 0 is 0. Okay, so I got a lot of zeros so far. Zeros are very powerful in matrices. Alright, then let's try some other numbers. Running out of colors, of course. Alright, let's try A12. Okay, so what are we going to do? We're going to do the first row with the second column. Okay, so that's 2 times 1, so we get 2. And then, for A1, what haven't I done now? A1, I've done A11, A12, I need to do A22. Okay, I want to do second row, okay, with the second column. So that's going to be 3 times 1 is 3. And then finally, I think we're almost there. Let's see here. Have I done lavender? I haven't done A32 yet. Okay, so here I've done all the 1s, and here I have to do all my 2s in the column part, right? So A32. I need the third row, okay, with the second column, this one. So I have 4 times 1 is 4. So put all these numbers into a matrix, and it starts to look something like this. 3 rows, 2 columns, so it's got about that aspect ratio. And let's put them in. A11 is 0. A second row, first column, 0. A third row, first column, 0. So all the first columns were 0. Now these are all my second columns, okay? But first row, 2. Second row, 3. Third row, 4. So I've come up with an interesting product of those two matrices. Now this was a little bit easier because I had the 1 in the middle, so I only had to do one pair of numbers every time I multiplied. So let's do one more now where we have to do a little bit more work. Okay, I'm multiplying together a 1-row, 4-column matrix times the second matrix, which is 4 rows and 1 column. And you have to decide if it's even possible, and you say yes, these middle two numbers are the same, so we're good to go on multiplication. And I know my answer, oh this is fun, is going to be a 1 by 1 answer. Okay, so this answer is going to be a 1 by 1. It'll be fun to see what a 1 by 1 looks like. We haven't really talked about that. Alright, so let's do this. So I only have one entry in my 1 by 1 matrix, and that of course is A11. So what does that mean? It means I'm going to take the first row from this one times the first column of this one. So this is just going to give us practice on these multiple multiplication things here. What do? Looking at just the first pair of numbers, okay, you have 3 times -1. So this first times this first, okay? And then you're going to add, okay, the second numbers with the second numbers, 0 times 2. And then you're going to add, when you pair up the third numbers. And then finally, you pair up the last numbers. Let's see, the 6 and the 4. And then you just add up every combination of those products. So I have -3 plus 0 plus 0 plus 24. So my answer is 21. So A11, the entry in my matrix is A11 is 21, so put it in a matrix. It's only got one row, it's only got one column, and it just looks like that. So the number 21 is a single entry matrix, a 1 by 1. Alright, so I'm going to let you try one. Okay, so I want you to try this one. It's a 2 by 2 by a 2 by 2, so it's obviously possible, and your answer should be a 2 by 2. Remember, you're going to be using rows from the first matrix, and you're going to be using columns from the second matrix. Alright, pause it. I'm going to go do the answer as well. Alright, so my answer is this 2 by 2, 25, -50, -18, 13. If you got it, you are just doing terrific. If not, I'm going to run through this one more time. If you're still having trouble, don't worry, because we're going to do a bunch of these in class together. So here goes my explanation. I'm going to start with the answer for the element A11. So I will use the first row and the first column together to get 5 times 2 plus 9 times 6. So that gives me 10. Oops, maybe I did it wrong the first time. How'd I do that? First row, first column, 10. Yep, okay, so this is wrong over here. My bad. So that gives me 10 plus 54. That gives me 64 here in the A11. Okay, next one. A12. I still have the first row, but now I have the second column. So now, looking for the red numbers, I have 5 times a -1 plus 9 times a -5. So that's a -5 minus 45, and that is indeed minus 50. So I got that one right. I have no idea what I did wrong in the first one. Let's see. Let's try another one. A21. So far I'm one for 2, or 50%. Let's try this one. I need the second row with the first column. Okay, so I'm working on the greens. I'm going to take negative 3 times 2, and I'm going to add it to a negative 2 times 6. And that gives me negative 6 minus 12. That gives me negative 18. So it looks like I'm back on track here. And finally, let's do the last one, which of course would be A22. So the second row with the second column. Okay? Boy, is it really helpful to have these numbers. Okay? I'm sorry, not to have the numbers, but to have the colors to really help me sort of focus on which numbers to use when I'm doing this. Okay, let's do this purple computation. Negative 3 times a negative 1 plus a negative 2 times a negative 5. And I get 3 plus 10, and I'm getting 13 for the last one. So there I am with the one correction with that answer. So let's do a lot more of these in class and see how it goes with some practice. See you soon.